Hello Legacy students. So today we're going to look at factoring out a greatest common factor, which is the 5th section of chapter 8. What you're going to want to have on you, your notes, calculator, and then a pen or a pencil to write in your notes, of course. So you guys have factored out what's known as a greatest common factor before, or GCF for short. Here's just numbers. So if you think back when you first started to try to find when you did fractions, you had to find the greatest number that could go into two numbers, right? You've done this before. So I have 45 and 36. So let's list the factors or numbers who multiply to give you 45. So that would be 1 and 45, right? 2 can't go in. 45 divided by 2 is not a perfect number. 3 does, though. 3 and 15, right? Those two go into each other. Those two multiply, give you 45. And then 5 and 9 give you 45, okay? So then let's see what numbers does 36 have. So that would be 1 and 36, right? 2 and 18. 3 and 12. And 4 and 9, right? Oop, and 6. 6 is in the middle, right? 6 times 6. So now, let's look here. What numbers can do 45 and 36 share? What's the highest number that they both share? Well, I first noticed they both share, if I change it into a different color here, they both share 3s, right? Right here and right there. So they both share 3, but is that the highest number they both share? No, they both share 9. Notice how they both have a 9 in them. So your GCF would be 9 in that particular instance. What about 18 and 42? So let's list the numbers of 18. That's 2 and 9, right? 3 and 6. None others in the middle, right? Let's check 42. 1 and 42, 2 and 21, 3 and 14, and then 6 and 7, right? Sounds about right? So what numbers do they both share? Let's do our circling thing again. So they both share a 2. That's not the highest, though. They both share 3s. 6. 6 is the highest number they both share. So my GCF would be 6, right? You've done this before. If you remember finding a greatest common factor, you have done this before just with numbers. But now we're going to be factoring with x's as well. So just like we thought, what's the highest number of x's that I can take out of each of these? So that's the question you're going to want to ask yourself. Number of x's. So that's the question you're going to want to ask yourself. What's the highest number of x's I can take out of every single term? So let's look here. I have 3 x's, 2 x's, and 1 x. So what's the highest number of x's I can take out of every single one? How many do each of them have to spare? They each have 1 x, right? This guy has 1 x, this guy has 2 x's, that has 3 x's. I can't take 2 x's because this guy doesn't have 2 x's to give. He only has 1. So let's factor out an x. So we're going to put x in front of the parentheses. Now, what we're going to do then is there's going to be some stuff left inside parentheses. The stuff that, once we take out that x, we need to think. So we have this x cubed. So here's the question I need to ask. What would I have multiplied x by to get x cubed? Or, in another way, I'm going to take 1x out. How many x's am I left with? That's right, 2, right? X to the second, and be left with x to the second. If I take 1x out of here, that 5 is just going to kind of hang out there. I'm not messing with him yet. I'm going to have one x left over, right? X squared, take 1x, I'm going to have 1x left. And then 3x, I'm taking that x completely out. So I'm just going to have a 3 left. That is done. I have found the greatest common factor of my polynomial. So let's take a look here. How many x's can I take out of each of those? How many x's do both of those share? X squared, right? This guy has 5 x's, this guy has 2 x's. They both have 2 x's to share. So, if I take 2 x's off of this, I'm going to have 3 x's left. I take that x squared, technically dividing it away, if you want to think of it that way, dividing x squared away, cancels that out, and we're left with 3. So, x squared times the quantity, x to the 3rd power plus 3. If you would refoil this out, so distribute that in, you would get this same problem above. That is a good way to check your work and make sure you did it correctly. Now, what if the numbers can be factored out as well? So let's think. We need to use it in our heads. Let's look at the numbers first. What number can come out of 4, negative 24, and 8? What's the highest number that all of them share? 2 can go into all of them. Is that the highest number though? You know what? I bet it's 4. 4 can come in out of all of them, because that would be a 1, that would be 6, and that would be 2, right? Now, what's the highest number of x's that I can take out? I can take 1x out, right? So I'm going to have 1x on all of them. So let's think here. 4 divided by 4, that's a 1. So I'm going to be left with, and I take 1x out, x to the 4th, right? Take 1x out, that gives me x to the 4th. Subtract 4 divided by 24, that's 6, negative 6, right? Take 1x out, I'm going to be left with 2 x's. And then I divide 8 divided by 4, that's 2. And my x's, I already took that 1x out. So I am left with no x's at the end of that problem. So that is done. I am done factoring. Notice how the numbers inside don't have a common factor anymore. Let's try this one. So what can I take out of a 9, a 15, and a 12? A 3, right? 3 can come out of all of them. What's the highest number of x's? I have an x to the 6th, an x to the 4th, and an x to the 2nd. 2 x's, or x squared, right? That's the highest number I can take out of all of them. They each can give 2 x's. So then 9 divided by 3 gives me my 3 there. I'm going to take 2 x's out. So I had 6 to begin with. Taking 2 away, I'm going to be with x to the 4th left over. 15 divided by 3, that's 5 left over. X to the 4th, take away 2 x's, x to the 2nd. 12 divided by 3, 4. And now let's think x squared. I'm taking 2 x's out of x squared. That's gone, right? I've taken all that. So that is left over. That's the end of this video. We're going to do a little bit more work in class, and don't worry that we are going to work on this a lot more with GCFs, just so you can get a little more hand on this. But that's the end of the video, so see you later, Sabers.